So when we have to graph sine and cosine, all right, we are pretty much going to refer to everything we learned for the unit circle, okay? So on the unit circle, you've figured out now that if you have an angle, and let's say it's pi over 3, you know, it's in the first quadrant, and then when you make another full circle, you get back to the same point. When you make another full circle, you get back to the same point. So each time you make a full circle, how many pi are you going? 2 pi, right? So when you graph that, when you graph sine and cosine, it's pretty much the same. Every time you go over 2 pi, it repeats, you get to the same point. You go 2 pi, you get to the same point. Here is an example of a sine function, okay? So take a look at this point, for example. Okay, y equals 0. Now it looks like a wave. Sine and cosine are both waves. Now if I go over, and you see here on the x-axis, it goes from 0 to pi to 2 pi. When I go to 2 pi, I'm back at 0. If I go 2 pi in the opposite direction, I'm back at 0. And if I were to go 2 pi again, I would go back to 0. And if I were to go 2 pi again, I would go back to 0. Similarly, if I picked any other point, okay, here, if I were to pick this point right there, and if I were to circle 2 pi, get back to that same point, okay? So this is very, very important when we talk about sine and cosine functions. They repeat after every equal interval. So every 2 pi, every 2 pi, every 2 pi. So there is a set cycle. And for that, we call them periodic functions. All right? That's what periodic means. So same with the periodic table of elements. It just repeats after every 7 elements. Okay? All right. So on our graph, okay, in order to complete one cycle, we just said we have to go a distance of 2 pi, okay? So we say that the period of the sine function is 2 pi, all right? And it's the same for the cosine. One period of the cosine function is 2 pi. It repeats, all right? You will also notice the highest value sine reaches is 1, and the lowest value is -1. So it's always bound between 1 and -1. Same with cosine, always bound between 1 and -1. Okay? All right. So if you look at the sine graph, and then if you look at the cosine graph, all right, do you notice any similarities? They're both the same exact wave, right? And if I could move these waves, if I could take the sine wave and just like nudge it along a little bit, it would look exactly like the cosine wave. Okay? Right. Okay. Now, here is how the full-fledged equation for a sine and a cosine looks. All right? Now, we're going to graph our very first one, and we're going to use the unit circle as a guide. Okay? So if you take a look at this unit circle right now, take a look at pi over 6 or 30 degrees. Remember that this is what that triangle looks like, right? So if 30 degrees is the smaller angle, how big is that vertical side? Is it the 1/2 or is it the √3/2? It's the 1/2, the smaller one. So this is the √3/2. Now, to get to this point here, all right, how much would I go horizontally then? I would go a distance of √3/2, and then I would go up 1/2. So my distance in x would be √3/2. My distance in y would be 1/2. So you can see here, the distance in x is √3/2, and the distance in y is 1/2. Okay? Now, let me ask you another question. This is an angle of 30 degrees. What is the sine of 30 degrees? Based on that triangle? 1/2. And how about the cosine? Root 3 over 2. So we could also, rather than saying x and y, we could also say the first coordinate is the cosine and the second coordinate is the sine. Right? So now, if I'm at, let's say, 60 degrees here, how much is the y value there? Root 3 over 2. So that's the sine of 60. And how much is the x value? So that's the cosine of it.
Don't you always know that? Because
you do always know that. Absolutely, right? And I'm exactly. So it's just the same thing put in this format. So now, you see how the angles here go from 0 all the way to 2 pi if we go around the circle? Okay, so now take a look at this grid here. Okay? And look here, the y-axis goes from 0 to 2 and 0 to -2. The x-axis goes from 0 to 2 pi. So what we're going to do here is we're going to plot the points from that for the sine of theta on here. Okay? So remember, the sine are all of those y-coordinate points. Okay, so now let's take a look at this. When my angle is 0 here, how much is the sine of it? What's sine of 0? 0. So here on the y-axis, I'm going to put 0. Okay?
So you said when your sine is 0?
When sine is 0, when the angle is 0, sine is 0. Okay, and I'm just going to make this a little bit bigger. So this first one there, I haven't labeled it, but it's pi over 4 and then pi over 2. So let me just label it now. This is pi over 4, pi over 2, and then 3 pi over 4. And then it's 5 pi over 4. And that's 3 pi over 2. And 7 pi over 4. Okay, so at pi over 4, take a look at the unit circle. At pi over 4, what's the sign?
Root 2 over 2.
Pi over 4 is here. It's root 2 over 2. How much is that in decimals? Root 2 over 2? Anybody with your calculators? How much is it in decimal? Root 2 over 2?
No, we did that wrong.
Yeah, we have to calculate.
It's 0.7.
It's 0.707, exactly. Okay, so at pi over 4, the sign is 0.7, right? So look, if it's 1 all the way up to here, this is like 1, 2, 3, 4. So where is it? So like somewhere over there, right?
Oh, because that's
Mm-hmm. So it's like 0.25, 0.5, 0.75, 1. Okay, now at pi over 2, how much is the sign at pi over 2 if we go back up there?
1.
1. Okay, now at 3 pi over 4, how much is the sign? Root 2 over 2, which is 0.7.
Go up and down again.
Yeah. And then at pi, what's the sign? Pi? Sine? Pi, sine, it's the y coordinate. At pi, what's the sign? That's the y coordinate.
0.
0. And then at 5 pi over 4, the y coordinate, negative 0.7. And then at 3 pi over 2, the y coordinate, -1. And then at 7 pi over 4, that's in the fourth quadrant, -0.7. And then at 2 pi, 0. So, oh my goodness, look at that beautiful function. Okay, so now what I want you to do is the same exact thing for the cosine this time. So if for the sine we were looking at all of the y coordinates, for the cosine we're going to look at which coordinates? The x coordinates. All right, so I'll stop this recording for a minute. So go ahead and fill in the points for cosine and draw that graph. All right, so now that we know that this is what the sine looks like and that's what the cosine looks like, pay close attention to this. From now on, when you're graphing sine and cosine, you're not going to go through it as tediously as we did this one. Okay, it's not going to be as laborious as this one. So you basically know that the sine always starts on the axis. The cosine always starts at the 1. Okay, so we're always going to have 5 points. These are going to be the 5 points. 0, maximum, 0, minimum, 0. Okay? Here, maximum, 0, minimum, 0, that. So there's always going to be 5 points. So if you're going to do a sine, you start on the axis and then you just know, okay, I go up 0, down 0. Okay? If I'm going to do a cosine, I start up here and then I go 0, down, 0, up. Okay? And it's going to be the same thing every single time. We're not going to be plotting these like, minuscule tiny little points from now on. Okay? So let's move on to a few details here. I told you that this is what the equations for the sine and cosine look like. So now look, we have this A and this B and this C and this D. Each one of those has a different purpose in the life of this function. We're going to start with the A. That A value shows you how high the highs are and how low the lows are. All right? We call it the vertical dilation. So A provides a vertical dilation. Now, if you look at A and if you take the absolute value, so you strip it of its positive or negative, if that value is greater than 1, it means there is a higher amplitude. That means the highs are higher and the lows are lower. There is a compression if the absolute value of that number A is less than 1. So for example, 2 over 3, okay, 4 over 7, negative 1 over 2, right? The sign doesn't matter. It's the fraction that matters. It's the fact that it's less than 1 that matters. This means that there is a smaller amplitude. So it should have said larger and smaller, but that's fine. Okay, so what is amplitude? If you split the wave horizontally down the middle, this distance here is the amplitude. Okay, so it's from the center to the peak or the center to the valley. All right, that is A. That distance is A. All right, so here we're going to sketch these two graphs. So look, we have a sine x and a 4 sine x. So in that 4 sine x, what's the amplitude? It's this number 4, and it's just 4. Okay? Now, here's what we're going to do. I'm always going to give you a grid like this, and you're just going to put the x-axis down the middle. All right? Now, sine of x, we said goes from 0 to 2 pi, right? So here, I'm going to start at one of these marks, and I'm going to go from there. So this, I make it 0. From that point, I go 4 over 1, 2, 3, 4, and that's 2 pi. Total, you got to have 5 points. Okay? Now, if the first point is 0, the last point is 2 pi, what's exactly in the middle? Pi. All right? Now, let's look at the quarter point. If this is 0 and this is pi, what's in the middle of that? If this is a full pi, half of it is pi over 2. Okay? If you get confused, what do you do? So look at this one. I'm going to figure out this point. The point between pi and 2 pi. If you can't figure it out off the top of your head, you add the first point plus the last point, pi plus 2 pi, and then it's half of that, right? So this is going to be half of 3 pi, which is 3 pi over 2. So that's that point. All right? Now, I'm going to graph two graphs here. First, I'm going to graph f of x, the sine of x. All right? Okay, so sine starts at the 0. So just remember that. And then from that, I go up 0, down 0, without even having to think too much about it. So this is now f of x. Now I'm going to graph g of x in red. The difference between f of x and g of x is g of x has a 4 in front of it, so the highs are 4 times higher and the lows are 4 times lower. So I start at 0 again, but I don't go to 1, I go to 4. 0, 4, 0. There. You can use a different color, or you can just label like this with the same color and it's the same. So one is f of x and one is g of x. Okay? All right. Most of the time, like on the homework, you're only going to have one to graph. I just did this to show you guys the difference. Okay? The difference is that the first one goes up and down to 1 and -1. But the red one goes up to 4 and down to -4 because there is a 4 in front of it. Okay, so this one, same situation. What's the amplitude of this g of x? 1/2, right? So its sine, we're going to go from 0, 1, 2, 3, 4 to 2 pi. And the values are the same. All right, so let's graph f of x. I start at 0, up to 1, 0, down to 1, 0. Okay? So that's f of x. Now, g of x, same deal. But how high do I go? From here I go just a half, and then 0, just a half, and then 0. Oops, not cool. Okay? So that's a tiny little amplitude. All right, ready to do a cosine?
Oh,
Yeah. Yeah. So what's the amplitude of that cosine? 2. All right, let's put the, yeah. Okay. So again, we're going to go 0, 1, 2, 3, 4. And we got pi in the middle, pi over 2, 3 pi over 2. Let's do the simple cosine this time. Sine started at the axis. Cosine is going to start at the 1. So cosine starts at the 1. And then I go to 0. I go low, 0, high. So you're always going to alternate between high, 0, low, low, 0, high. And it looks like this. Please give it that wave on the ends. We don't want it to look like a V, okay? Now, this next one is 2 cosine x. So all the highs are going to be, twice as high. All the lows are going to be twice as low. So I start at 0, 2, 0, low, 0, high. Okay? All right. Now, so that's one excitement. Now, another piece of excitement that we can add to this is what happens if that number A is negative? So what happens if it's -2 cosine instead of just 2 cosine? Well, when the constant A is negative, the graph is reflected around the x-axis. All right, that means it's flipped around. It's the reflection. So let's take a look at this one. What's the amplitude of g of x here? +2. So for amplitude, we always strip it of the sign, and it's just +2. Now, here's how it's going to look. So for this one, I'm only going to graph g of x. Okay, we're going to start at 0, go over 4. Pi over 2, 3 pi over 2. Okay, now, here it is, g of x. If it was 2 cosine, we would have started at up 2. Now, because it's -2, we're going to start down 2. And then go to 0, high, 0, low. Okay, so let's compare that to the one we just did here. Okay, this is right side up. This is a reflection. Okay, it looks like this. All right. And if I could move it, oh, I guess I can't move it. So you can put the 0 wherever you would like. What I would like on the test or quiz or even homework, all right, I would like to see that you have labeled all of those 5 points. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. That all 5 points are listed on the x-axis. And I just want to see those points. All right. So, with that, you will be ready to do your homework.